the topic that we're going to see today is basically on the token bus LAN. So we have not talked a lot about the token ring and basically the concept of token passing. So ultimately the idea here is you're going to have a controlled access, unlike the random access scheme where you're going to control it by circulating the token. So one who gets hold of the token is the one who's actually authorized to transmit the frame, but how long they can basically transmit the frame, there is going to be some limitation so that you don't monopolize by taking control over the medium. So here we actually very comprehensively studied about 802.5 token ring, where we analyzed what are the different ways in which you can actually reinsert your token, when can you release the token, how is the latency going to affect the efficiency of the utilization of the ring, right? How do you handle priorities with respect to stations who has frames, rather than going on with a round robin fashion and all that. But ultimately the topology is basically a physical ring. Now just imagine, initially it was not the ring, it was the bus topology that was there when Metcalfe was basically working on Ethernet, where he had the bus topology, and he used this carrier sense concept to basically use the medium. IBM was working on claiming having a controlled access by using this concept of token. So the first thing that was standardized was basically the concept that having the concept of controlled access using token in a physical bus topology, right? That was standardized as 802.4, and then only followed the ring kind of a manner, where it was actually standardized at 802.5. So 802.4 is of use scope now because it is not basically going to be used as bus topology, is no more as kind of topology used. So yeah, apart from that, there is fiber distributed data interface as well, which is actually a dual ring based on fiber links, but on a ring topology. Anyway, so we will work on this 802.4 standard, which is basically the token bus LAN. So as I told you, it's a physical bus topology, but the idea here is token is going to be circulated in a ring fashion logically. So what you are going to do here is we are going to bring in the logical ring topology with respect to how your tokens are going to get circulated. Okay, so it's not a physical ring, it is a logical ring in terms of the circulation of the tokens that is basically going to have. So how is that are you going to circulate your tokens? Now the idea here is, in that sense, you are physically connected to the next station, and you are physically connected to the previous station in a form of ring manner. So you don't need to put the address of who's going to be the next station who can actually get the token. You typically pass the token. Since it's a unidirectional link, the station who's actually going to get the token, free token, is the one who's actually going to use it. Okay, so that's basically the idea. But here, since that we have a common bus, we need to have a mechanism to specify in the token frame itself the address. Okay, so whichever station is there in the token frame with its address is the one who can actually go on to use the token. So we're going to have an address hierarchy. Okay, address hierarchy meaning you're going to have all the stations being sorted in a kind of a based on their MAC address, you're going to actually sort. So the next station to whom you're going to circulate the token, which is basically your successor, is the one who's having the next highest MAC address compared to you. Okay, so how is that we're going to follow this address hierarchy? We have to come up with some control management frames to basically find out who's going to be your preceding station, who's going to be your successor station. So that is one thing there, but you need to close the ring. So ultimately what happens is that the final highest address station should be closing out with the lowest address station in a logical manner. But please understand, we are not bringing any relation here between the physical location of the station to its address, because in the bus you can go on to tap any station. It is not necessary that the stations should only be placed in the bus in the sorted MAC order. That is impossible. You just keep your MAC address will be random. But the idea here is, though your physical location, your MAC address is not sorted, logically you try to follow a sorted kind of an address hierarchy so that you can circulate your tokens. So to actually justify that fact, now here you see the picture where you basically have several stations whose MAC address is known. This is just for your understanding that there are some numbers, and this is how it is placed in the bus. But you also have to see that the stations MAC address are not basically in a sorted order. They can be any order, but the ultimate idea here is this physical topology. We need to actually form a logical topology in the form of ring, such a way that the token is going to be passed in a hierarchical address manner, meaning the sorted order based on the MAC address. The next token has to be passed to the next highest MAC address. And so from 81 it goes to 128, and 128 it goes to 156, and the last highest address gets connected to the lowest address in the station, right, to close the ring. So it forms a logical ring, but ultimately the token is going to be placed on the common bus. And so how the station will come to know that he can go on to take the token is by looking at every station will go on to ponder the destination address in that particular token and see if it is basically for them. So this is basically the token passing sequence concept that is basically followed in the token bus, unlike token ring where you don't need to specify the address in the token who basically can go on to claim. Okay, so we're going to do this. The token holding station